Hello all. In this session, let me learn about one of the combinational logic circuit, which is a multiplexer. So now, based on your types of multiplexer, we will learn about 4 to 1 line multiplexer, 8 to 1 line, and how to design a higher order multiplexer using low order multiplexer. So now, what is a multiplexer? Is one of the combinational circuit which would have 2 power n number of data inputs and with a n number of selection inputs and with one single output line. One of these data inputs will be transferred to the output terminal based on your selection input combination. Since there are n number of selection inputs, so based on your 2 power now n number of inputs, so which you can substitute your zeros and ones on your inputs of your multiplexer, and based on the logical values which you substitute on your selection line, out of the 2 power n number of inputs, one of the input is transferred to the output terminal. So it is also called in a short form as mux, and it converts that 2 power n data into a one output terminal. Hence these are utilized in data transmission, which can convert your parallel data into serial form. So in such type of applications, we're going to prefer your multiplexers, and it can convert your parallel data into a serial data, as well as it can convert that many number of inputs into your one output. So hence it is also called as many to one circuit. Now, so these are the basic 4 types of your multiplexer based on the order of the multiplexer or your number of inputs and your outputs available on your multiplexer. So 2 by 1 multiplexer, 4 to 1, 4 to 1 multiplexer, 8 to 1 multiplexer, and 16 to 1 multiplexer. So in this 2 by 1 multiplexer, you have 2 inputs, only one output terminal. To transfer that 2 inputs through your single output terminal in a single on a single time, so only one input must be transferred based on your selection input. So these selection inputs are acting like a control signals. So in 4:1 multiplexer, number of inputs are 4, and these 4 inputs are transferred through your single output terminal based on your selection input combinations of 2. So S0 and S1 are the selection inputs of your 4:1 multiplexer, whereas in 8 to 1 multiplexer we have total number of selection inputs are 3, so which are designated with S0, S1, S2 are the control inputs which are used, or selection inputs which are used based on your logical levels what to substitute on your inputs. So one of the input is transferred to the output. So in 16 to 1 multiplexer, the possible inputs are 16, so you can write your 16 with the 2 powers as 2 power 4. So this n designates, so that 2 power of this 2 indicates your number of selections required in order to design that particular order multiplexer. So now, so 16 I can write in 2 power is 2 power 4. So we require total number of selection inputs are 4 selection inputs, and they were designated from S0 to S3. So number of inputs are 16, number of selection lines are 4, and it will transfer your these 16 inputs through a single output terminal using your selection inputs of 4. Next, let me move to your in-depth details about your 2:1 multiplexer or 2 by 1 multiplexer. So now in this 2 by 1 multiplexer, it has only 2 inputs and labeled as A0 and A1. Only one selection line is required to transfer these 2 inputs through a single output terminal Y. So now on the basis of this combination of inputs, so that we can represent the selection in lines are S0. One of these 2 inputs are forward to the output line. So now it is the simplest type of your multiplexer in digital electronics. Next, here in 2 by 1 multiplexer, we were going to explain the operation as well as the how to design your 2 by 1 multiplexer is using a block diagram and truth table. Now, so here we mentioned the block diagram with a control input, which can switch on or switch off. This enable can switch on or until unless this enable is in high state, so your circuit become off and your output become 0, so no input is transferred to the output. So whenever this enable input is in on state, then based on your selection input, if selection input is 0, your first input is transferred to the output. If your selection input is 1, the second input is transferred to the output. So we wrote that in your truth table with the selection inputs as we have taken as inputs, and the output only is one single output. So now based on your selection inputs, so which input is transferred to the output? So this input is also in the form of binary, so those values might be a 0 or it might be 1. So hence we mentioned generally as a naught here. If S0 is 0, first input is transferred to the output. If S0 is 1, the second input is transferred to the output. And now we will draw the block diagram. Block diagram is over here, and with the truth table, we were going to draw the logical diagram of your 2:1 multiplexer or 2:1 multiplexer. Now output Y here from this truth table is sum of your, so it depends on your selection number of selection inputs. So if S0 is 0, so which is denoted with the complement of S0, your output is equal to A0. So hence, so S0 into A0. So if S0 is 1, then it will transfer your input which is A1. So hence the output expression from this truth table, Y is equal to S0 bar into A0 and plus of S0 into A. So now let I first assume S0 is 0. If S0 is 0, so using this expression, let I replace S0 with 0, 0 bar into A0 plus S0 value is 0, 0 into A1. So now 0 bar is equal to 1, 1 into A0 plus 0 into A1 is 0, which is equal to A0. So since that if S0 is 0, it transfer the first input to the output. Now using the same expression, if S0 is equal to 1, so now replace your S0 with 1. So 1 bar into A0 plus S0 is 1 into of A1. So as 1 bar is complement of 1 is equal to 0, A0 plus 1 into A1. So now here we obtain this 0 plus of 1 into A1 is A1. So hence y is equal to A1 if S0 is equal to 1. So like this, so based on your selection input combination, one of the input is transferred to the single output terminal. So hence our output Boolean expression for the output single output is equal to S0 bar into A0 plus S0 into A1. In the same manner, let me go to design your 4:1 multiplexer, where this 4:1 multiplexer is having total number of inputs are 4. Since it is having 4 number of inputs to be transferred to the output, we require the number of selection lines are 4 can be written in terms of power of 2 is 2 square. So number of required selection lines are 2 number of selection lines we require. We label that with the S1 and S0. So if S1 and S0 both are 0, then here the output will become, it will be transferred with your first input terminal I0. If S0 and S1 are 0 1, so I1 is transferred. If S0 and S1 are 1 0, then I2 is transferred. When S0 and S1 are 1 1, I3 is transferred. Now let me go to the writing here output expression of this 4:1 multiplexer. So I0 is transferred if S0 and S1 both are 0 as a product term. Let I write as your S1, if it is 0 means, so we have to represent that with complement. S0 is also 0 into of I0 plus of your, so plus, so S1 bar into S0 into A1. So second input is transferred. If S1 is 0, S0 is 1. So third input is transferred if S1 is 1, S0 is 0 into of A2 plus last input which is A3 is transferred or I3 is transferred. So if S1 and S0 both are equal to 1s. So like this, one of the input is transferred to the output, single output terminal of your 4:1 multiplexer. Now using that Boolean expression of Y, so let me draw the logical diagram. So this resembles as a SOP expression. So now, so we are adding the product terms using an OR gate. So hence output obtained from this multiplexer is output of your OR gate is considered is as a Y, and your inputs of this OR gate comes from your outputs of the AND gates. So each AND gate will give you the one of the product term. So first one, so in order to transfer S I naught, we need to connect the two inputs from S naught bar and S1 bar. S1 bar. So hence that product term is now it will become S1 bar into S0 bar into I0. So next to transfer I1, S0 must be 1, S1 is 0. So hence S0 into I1. So now here we'll connect S1 must be 1, S0 is 0, and then we are going to transfer I2. Next, the last AND gate has to transfer your I3 input. So both S1 and S0 are at logical level. Then only I3 is transferred. So hence we have connected that two input lines from your S1 without complement of your S1 and S0 line. So and it has been transferred, one of the input of your AND gate is transferred from your I3. So now based on your selection lines, if it is 0 0, I0 is transferred to the output single output terminal. If it is 0 1, I1 is transferred. If it is 1 0, I2 is transferred. If it is 1 1 on selection lines, I3 is transferred to the output. In the same manner, so now let me construct an 8 by 1 multiplexer where it is having total number of inputs 8 inputs started with A0 to A7. So as we have 8 number of inputs, I can write with the 2 power. So now 8 is written with the 2 power 3. So number of selection lines required to transfer these 8 multiple inputs through a single output terminal is 3. So hence we label that with S0, S1 and S2 are the selection lines of your 8 by 1 multiplexer. If all are 0, first input is transferred. If it is 0 0 1, second input A1, so 0 1 0, A2 is transferred 0 1 1, A3 is transferred 1 0 0, A4 1 0 1, A5 1 1 0, A6 and 1 1 1, A7. So this represents the block diagram and this belongs to your truth table of your multiplexer of 8 by 1. Next, Boolean expression of your 8 by 1 multiplexer, since A0 is transferred if all the selection inputs are 0. Since we have represented each selection line as a complemented variable in the product term of your Boolean expression as one of the product term. So now we have connected S0 bar, S1 bar and S2 bar as the input along with your A0. So hence it will give you the first AND gate will give you the product of S0 bar, S2 bar, S1 bar, S0 bar into of A0. If all are 0, Y become A0. If it is 0 0 1, so then Y become A1. If it is 0 1 0, Y become the A2 value. So like this, so based on your logical expression using your 8 number of AND gates along with a 8 input OR gate, so we are going to implement the logical diagram of your 8:1 multiplexer with 3 selection inputs. So in order to obtain the complement of your selection input, we use the NOT gate. So like this, we are going to construct your 8:1 multiplexer. To implement your higher order multiplexer using low order, so for example, 8:1 multiplexer, if I want 8 by 1 multiplexer using 4 by 1 multiplexer, we require 2 number of 4 by 1 multiplexer, along with that 2 by 1 multiplexer, as you have only one single output terminal. Now in order to construct that, so let me take the truth table of your 8 by 1 multiplexer, which is having 3 selection inputs, but a 4 by 1 is having only 2 selection inputs. So those 2 selection inputs are commonly connected together and have been given as S1 and S0. So in order to construct a 8 by 1, in addition with this 2 4 by 1 multiplexer, we need to use your one more 2:1 multiplexer, where that selection only it require, as it is having 2 inputs, only it require the one selection input. So the higher order selection input of your 8 by 1 is connected to the second level 2:1 multiplex. In the first level multiplexer, we were going to connect commonly from your upper 4 by 1 multiplexer and your lower 4 by 1 multiplexer selection lines are connected, and they were taken out as S0 and S1. So now based on your S0 and S1, so it can select one of the multiplexer, and your S2 can select, so only one output should transfer through your output of your Y. So if S2 is 0, it transfers the lower multiplexer output. If S2 is 1, so it will transfer the upper multiplexer 4 by 1 multiplexer output. Now the lower multiplexer output, as it is a 8 by 1, so first 4 inputs I0 to I3 are connected to the lower multiplexer, and the remaining higher order multiplexer inputs I4 to I7 are connected to the upper multiplexer. If S0, S2 is 0, S1 and S0 are both zeros. So now out of this S0 and S1, so our first input is transferred to the output. So both multiplexer are being selected here. So it will transfer first 4 by 1 upper multiplexer will transfer I4, and your lower multiplexer will transfer your I0. But since S2 is 0, the first input is transferred as your output. So when S2 is 0, I0 is transferred to the single output terminal Y. The same manner, if your S2 is 1 and then S1 and S0 are 0, 0, so it will transfer not your I0, it will but it will transfer your I4. Since S2 is 1, so 2 by 1 multiplexer, which is in second level, will select the second input, and that second input is transferred from your upper 4 by 1 multiplexer. Like this, so it will use your 2 4 by 1 multiplexer along with a 1 2 by 1 multiplexer. We can implement your 8 by 1 multiplexer. So like this, so we are going to design your higher order multiplexers using your low order multiplexer. Thank you.